I want you to imagine, just for a second, that you or someone you love very much is dealing with a really complex, frightening illness.
Right, which is unfortunately a reality for so many people.
Yeah, exactly. So you are navigating specialists, imaging centers, lab draws, and pharmacies. And I want you to look around that clinical waiting room and ask yourself, who in this entire sprawling medical system holds the complete whole picture of your care?
It is a great question. And usually the answer is pretty terrifying.
It really is,
Yeah.
because who actually knows every appointment, every conflicting medication, every delayed test result? The startling reality is that today, the only entity holding that entire picture is usually you, the patient.
Yeah.
And you are probably armed with, like, nothing more than your own exhausted memory and a thick, overstuffed manila folder. I mean, we have literally built a system that relies on the sickest, most overwhelmed person in the room to be its master integration engine.
That is exactly the fundamental flaw right there.
Yeah.
It is our complete reliance on implicit labor.
Implicit labor.
Right. Yeah. I mean, we are taking the person with the absolute least amount of medical training, who is currently operating under massive physical and cognitive distress, and we're essentially assigning them the job of project manager for their own survival.
Wow. It's incredibly heavy when you put it like that. And this brings us to the mission of today's deep dive. I've got a massive stack of sources in front of me today.
We really do. Some fascinating stuff.
Yeah, medical journals, systems engineering research, and at the center of it all, a comprehensive conceptual model prepared by F. George called the Loom.
It is a brilliant framework.
It is, because for decades, stakeholders across the healthcare spectrum have been calling for better care coordination. But with every, breathtaking advance in medicine, true coordination seems to slip further and further away.
Yeah, becomes more fragmented.
Exactly. So today we are exploring how, with the rise of digital medicine and multi-agent artificial intelligence, we might finally be able to see the distinct threads of a patient's care and spin their yarn in such a way that a digital loom can guide the orchestration of that care without losing the human element.
Right, and if we connect this to the bigger picture, the goal isn't just to, throw more software at a broken system. We've tried that.
Oh, definitely. We've all seen the messy portals.
Exactly. The objective here is to actually understand the underlying architecture of medical logistics. Because right now, the way we handle care coordination is essentially leaving it up to chance.
Yes, and good intentions.
And good intentions, yeah. Plus the massive unpaid labor of patients and their families.
Okay, let's unpack this. Because before we can even talk about using AI software agents to fix coordination, we have to actually define what coordination is.
Which is harder than it sounds.
Right. The source text points out something brilliant. It says we currently treat coordination as this single, vague virtue, like being good or being patient.
Yeah, but it's not a virtue. It is actual work.
Exactly.
And if you can't name the work, you can't assign the work. And right now, because the work is treated as this vague concept, when it fails completely silently.
Silently.
Yeah, think about a smoke detector. If it loses its battery, it chirps, right?
Yeah.
It demands your attention.
It's super annoying, but you fix it.
Precisely. But in healthcare, no alarm sounds when a specialist referral is just never closed. No siren goes off when an abnormal lab result is filed away and never acted upon.
Oh, that's terrifying.
Or, when two different specialists unwittingly order the exact same expensive scan just a few days apart, the system just quietly absorbs the failure.
Wait, so when people complain about bad care coordination, I honestly just think about the annoyance of having to drive to the hospital 3 times in a single week for different tests.
Sure, that is the classic complaint.
But is that really the core problem this model is trying to solve, just the scheduling?
No, not at all. That is just one fraction of the problem. The source breaks this vague virtue down into 9 distinct domains.
9. Wow.
Yeah. So what you were describing is the temporal domain. Bundling appointments, managing the calendar. It is the most visible to us as patients, but it's just the surface.
Okay, so what are the deeper ones?
Well, you also have the transitions domain. That handles those incredibly risky handoffs when a patient goes from the highly monitored environment of a hospital back to their home.
Right, where things can easily fall apart.
Exactly. And then you have the patient and caregiver domain, which explicitly calls out that invisible labor of system navigation we were just talking about.
Right, and the text points out that the real, life-threatening danger often hides in the diagnostic domain.
Yes. Diagnostic coordination is arguably where the most devastating silent failures happen.
And this is where the concept of life cycle grid comes in, right? Because coordination isn't a single action, it's a cycle.
Exactly. Under this model, Diagnostic coordination is not just a checkbox. It is a rigorous 7-step sequence.
Walk us through those steps.
Sure. First, someone has to actually notice a test was even ordered. Second, the system needs to check it against tests that have already been done.
To avoid that duplication we mentioned earlier.
Right. Third, there has to be a decision on whether it's still clinically needed based on new data.
Okay, that makes sense.
Fourth, it must be sequenced sensibly. Fifth, actually executing the order. Sixth, closing the loop on the result.
And then there's the 7th step.
Yes, the crucial one. Ensuring an abnormal result is actually acted upon.
That 7th step is where the baton just gets dropped so often.
It really is.
A test is ordered, the lab runs it, a result comes back abnormal, but because no single person owns the space between the specialist who ordered it and the primary care doctor who received a copy,
It just gets lost.
yeah, the result just sits in a digital filing cabinet. No one acts on it.
And that grid, the 9 domains crossed against those 7 life cycle steps, represents the full, comprehensive map of the work.
It seems massive.
It is massive, but as the author notes, it is finite. And finite work, no matter how complex, can be managed by a system.
So if that massive cycle of tasks is running for every single medical event, what happens when a patient doesn't just have one issue?
That is where the current system totally breaks down.
Right, and this is where the source introduces a case patient to really anchor the concept. And suddenly the system's breakdown becomes terrifyingly clear.
Let's look at that case patient. She is a woman living with type 2 diabetes and heart failure with a reduced ejection fraction.
And for anyone following cardiology, you know that means her heart muscle is fundamentally compromised. It isn't pumping out enough blood with each contraction.
Exactly. It's a delicate condition. And to compound all of this, she has just been diagnosed with stage 3 cancer and is starting chemotherapy.
I mean, just hearing that list of conditions is overwhelming.
It is a huge burden.
You have a primary care physician managing the diabetes, a cardiologist managing the failing heart, and a medical oncologist attacking the cancer. They are all pulling threads.
But they can't see each other's hands.
Exactly. A traditional approach would try to solve this by creating one single master plan for the patient, right?
Right. But the model argues that a master plan fails completely in this scenario.
Why is that?
Because these disease pathways don't run politely in parallel, they actively interfere with one another.
Right.
For example, the chemotherapy drug the oncologist selects might be incredibly effective against the cancer, but it is also highly cardiotoxic.
Oh, meaning it damages the heart.
Yes.
It's like trying to cook a massive holiday dinner where the turkey recipe, the pie recipe, and the stuffing recipe are all actively fighting over the exact same oven temperature and timer.
That is a great analogy.
You can't just mash them into one single master recipe without ruining the whole meal. Like, the turkey wants 4 hours at 325 degrees, the pie needs 425 for 15 minutes, and the stuffing demands to be covered.
Right.
They're fundamentally incompatible if you try to read them as one merged document.
The interference is the core issue. And that is why a team of software agents is the right shape for this solution, rather than one giant monolithic algorithm.
Mm-hmm.
To quote the source text directly, the heart problem is not running one patient's plan. It is weaving several plans, owned by different teams, into one cohesive whole, without losing the integrity of any single thread.
Wait, so you're saying we are going to treat my mother's cancer treatment and heart failure like a supply chain logistics map?
Essentially, yes.
Doesn't that remove the human element of medicine entirely? Like, how does software actually solve that interference without just making a giant fragile master plan?
Well, it doesn't replace the medicine. It manages the logistics so the human element can actually happen.
Oh, okay.
To build this architecture, which the author calls the Loom, the first thing you need is a condition library.
A condition library.
Yes. These are mapped out care pathways for specific diseases, built using BPMN and DMN.
Which stands for business process model and notation, and decision model and notation, right?
Correct. It's a standardized way of mapping out processes and decision logic that is used every day in manufacturing and finance.
So bringing industrial tools to healthcare.
Exactly. It takes a messy reality and maps the flow of tasks and the branching decision points. And inside the condition library, you have 2 types of these maps.
What are they?
You have baseline chronic loops, like the maps for her diabetes and heart failure. These are always on, running quietly in the background, constantly watching for gaps in care.
Okay, and the second type?
And then you have episode maps, like her sudden cancer diagnosis.
So the cancer map is triggered by a specific event, like her biopsy result coming back positive.
Yes, exactly.
It runs hot and fast during her treatment, demanding a lot of resources, and then eventually turns off or shifts into a surveillance mode.
Which brings us to how these maps actually interact. The source outlines 4 main parts to this basic framework.
All right, lay them out for us.
First, you have the conductor. This is crucially a human being, usually the primary care physician, who owns the integrated plan and hold ultimate clinical accountability.
Okay, human in charge. Got it.
Second, you have the orchestration loop. This is the software engine that actively pulls those maps from the library, runs them step by step, and retires them when they are completed.
And the third part.
Third is the patient portfolio. This is the live, active set of maps this specific patient is running right now.
So for our case patient, her portfolio currently holds the diabetes baseline, the heart failure baseline, and the cancer episode map, all running simultaneously.
Exactly. And the fourth part is the namesake of the entire model, the Loom.
Ah, the Loom.
Yes. The Loom is a small set of shared surfaces where all these different independent maps project their needs.
What kind of surfaces?
Well, there's the timeline, which is the literal calendar every map is fighting over for appointments. There's the state ledger, which holds shared clinical facts like recent lab results.
Right.
And there's the constraint surface, which holds the clinical rules a specific map imposes, like the heart failure map, demanding severe fluid restriction.
And the surface that really caught my eye in the research is the burden budget.
Yes, that is a vital piece.
It is such a brilliant, empathetic concept. It acknowledges that the patient has a finite capacity in terms of, physical energy, financial resources, and travel ability.
Absolutely.
The maps have to draw from that budget. And when it's empty, the system has to recognize that the patient simply cannot handle another crosstown appointment this week.
It completely quantifies the patient's lived reality as a systemic constraint.
Here's where it gets really interesting.
Yeah.
There is a cardinal rule to this entire architecture.
Well, the big one.
Yeah. The maps in the portfolio are never allowed to reference each other directly.
Right.
Like, the cancer map literally does not know that the heart failure map exists. The source is absolutely adamant about this. Quote, do not braid the threads into one thread. But why keep them blind to each other? Wouldn't a smart AI want to look at the whole picture?
You'd think so, but this raises a really important question about system fragility.
How so?
If you tried to write a merged, highly aware master map for a patient with diabetes, heart failure, and cancer, the complexity would be astronomical.
Just too many variables.
The branching logic would be impossible to maintain. And the second she develops a fourth condition, say, she catches pneumonia,
Oh, man.
that master map instantly collapses because it wasn't programmed for that specific four-disease combination.
That makes a lot of sense.
So by forcing every independent map to remain blind and only project its needs onto the shared surfaces of the Loom, you keep the library clean.
The weaving happens at runtime.
Exactly. It happens on the patient's actual calendar and their physical body.
So the software agents are just running the highly predictable, deterministic steps of the map. They're just doing the math.
Yes.
Checking the calendar, reserving the burden budget, noting the constraints. They aren't actually making the ultimate clinical trade-offs, are they?
No, they aren't. The engine walks the map step by step. The agents weave the data across the surfaces.
They lay out the logistical threads so a human clinician can clearly see the knot.
Perfectly said.
Which is perfectly demonstrated when the creators of this model put it through an intentional stress test.
Right, because a theoretical architecture looks great on a whiteboard.
Exactly. But what happens when it hits our case patient in the real world, where her conditions are actively attacking each other's rules?
The stress test is where the initial model really strained, and the resulting rebuild is where the true innovation lies.
So what happened in the test?
Well, in our patient's case, the chemotherapy she desperately needs for her cancer is highly cardiotoxic.
Bad for the heart.
Very bad. Furthermore, to deliver that specific chemotherapy safely and protect her kidneys, the oncology map demands aggressive intravenous hydration.
Pump her full of fluids?
Yes. But her heart failure map is screaming the exact opposite. Her weakened heart cannot pump effectively. The absolute golden rule of her cardiology map, projected right there on the constraint surface, is strict fluid restriction.
So if you pump her full of IV fluids to save her kidneys from the chemo,
Her lungs will fill with fluid and she will go into respiratory distress.
that is a nightmare scenario.
It is. And when they ran this scenario, the basic framework of the model struggled. It assumed that these conflicts were just complex math problems that a multi-agent algorithm could eventually optimize away.
But you can't just split the difference on IV fluids. You can't give her, like, medium fluids.
No, you can't.
You're deciding which organ takes the hit to save the patient's life. These aren't math problems. They are human judgment problems.
The developers recognized this, and they had to rebuild the model to account for clinical reality.
So how do they fix it?
They added 4 key components to resolve these existential strains. First, they explicitly placed a named clinician above the software loop.
Oh, I like that.
The software proposes a schedule or a treatment path, but a human takes accountability for the final integration.
Okay, what was the second thing?
Second, they added a goal and decision surface. If the computer can't mathematically reconcile the schedule or the conflicting treatments, it doesn't just guess or force a bad compromise.
It flags the collision.
Exactly. It flags it and escalates the conflict upward for human deliberation.
Brilliant. Third,
They introduced an interaction library. This is a curated knowledge base of cross-map clash rules.
like a warning system.
Yes. So the system is pre-taught that when heart failure with reduced ejection fraction and this specific chemotherapy co-occur, a red flag must be raised instantly on the constraint surface.
And fourth, which might be the most radical departure from how medical records work today, they added a ledger that holds dispute.
This is huge.
Because right now, a medical record is treated like a book of unquestioned facts. But this model allows the record to hold contested interpretations. It might literally say, ejection fraction 35%, attribution disputed between cardiology and oncology.
What's fascinating here is that the system is designed to coordinate on honest uncertainty, rather than forcing a false, dangerous consensus.
Because in legacy systems, someone usually just overwrites someone else's note, right?
Exactly. But this model refuses to force the computer to make a clinical trade-off. It perfectly tees up the conflict, documents the disagreement, and ensures the human doctors know exactly what they need to debate.
And in that rebuild, they introduced this concept of goal provenance,
Yes.
making sure the system actively tracks where a medical goal came from. If the goal is, say, comfort care only, the system demands to know, was this goal set by the patient herself?
Or a proxy.
Right. Was it set by a proxy, like her daughter? Or was it derived by the medical specialty team based on clinical guidelines? So what does this all mean for the patient's voice in a highly automated system?
It means the patient's voice is structurally protected, not just assumed.
That is so important.
The system acknowledges that sometimes a patient is too sick or too overwhelmed to set their own goals in a given moment. But it treats patient authorship as the ultimate destination.
Wow.
The system is always reaching to return agency to the patient, and it makes it completely transparent to every doctor on the care team who is currently speaking for them.
This is such a radical shift in how we view the system. To bring this deep dive back to you, the listener, we started by looking around that waiting room and realizing the burden of coordination falls almost entirely on your shoulders.
Is a heavy burden.
It really is. The ultimate goal of the Loom isn't just a neat software trick to optimize calendars. It is trying to take care coordination from being this heroic, invisible, and totally unpaid labor and turn it into a governed, visible, and improvable system.
It completely rejects the current paradigm of just asking doctors and nurses to, well, try harder to coordinate.
You can't just try harder.
No, you can't try harder when you are blind to the other threads. And you certainly can't ask a sick patient to project manage their own complex care pathway.
Right.
This model gives clinicians a structured loom to weave those threads together, but it insists that a human hand is always on the score.
It gives the work a structure that can actually be trusted. Which leaves us with a final, somewhat provocative thought to ponder as we wrap up today.
Let's hear it.
If multi-agent AI and models like the Loom eventually succeed in perfectly mapping and coordinating all these logistical, clinical, and financial threads of our care, will the role of the primary care doctor shift entirely?
Oh, that is an interesting question.
Think about it. If the software is handling the scheduling, managing the burden budget, and flagging the drug interactions perfectly, maybe the primary care doctor is no longer just a fixer of bodies.
Right, their role evolves.
Maybe their primary job becomes being a negotiator of our deepest personal life goals against our incredibly complex medical realities.
That is a profound shift.
It really is. Something to think about next time you find yourself holding that manila folder.